I'm Matthew and welcome to my 52 project. To begin, I created a template with reference images that I grayed out. From there, I created a rough guideline for how the wings should look like. Once I did that, I looked online for the aerofoils of the F-4's wings and converted them to XYZ coordinates by adding zeros for the x's and turning all the z values negative. From there, I inserted them in SolidWorks and used the scale entity tool to change them from the unit length 1 to the size they needed based on the numbers I measured on the wing geometry created beforehand. I then lofted the wings section by section using the aerofoils. After that, I filled the gaps in between each section and then I mirrored and knitted the features together. Then I created a surface offset on the wing. Then I used split lines to mark the location of the control surfaces on the wings, using them as a template to guide my cutters and shape the radius of each new part. After that, I ran to my first problem, the split tool, because of the reference planes I was using beforehand when I was trying to cut the surfaces. This problem was eventually solved by referencing all the planes from the right plane, after which I was able to cut the parts out. After the parts were cut out, I used a trim tool to remove the rest of the split surface left over while also keeping the inner arc of each part in place, saving me time as they did not have to be modeled in afterwards. I repeated the same process for the spoilers and used the keep delete body feature afterwards to remove the surface offset. I then added some finishing touches to the top and bottom of the wing by using split lines created from a template that I drew over. Once the wing was done, next came the control surfaces where I created guides for the 3-point arcs before lofting the surface across and filling in the spaces between each part and the loft face. Then came the fuselage, which was made similarly to the wings, using surfaces that are lofted or swept to give the parts some of the curves it had. The main problem for the fuselage started when I started working on the tail, as numerous problems popped up from funky geometry to crinkled surfaces. I simply fixed these problems by making every line and point piercing around the surface one another, whereas for the tail, I had to spend a few hours breaking a large surface into multiple smaller pieces. With the plane basically done, I moved on to something more rigid like the weapon. I started with making 6 barrels with the circular pattern feature, which I repeated multiple times to create the shape of the part in tandem with the linear pattern feature. After that came the little detail like the rifling in the barrel, which was made with a swept cut on the spiral, which is then circular pattern multiple times, once to make more grooves in the barrel, another time to duplicate it to other barrels. For my simulation, I performed a static linear displacement test with a fixed end at the base of the Vulcan and 77,190 pound forces pulling down on the other end of the part. In the case where the gun is being bent down by the weight of the fighter and the amount of thrust it creates as it crashes to the ground. The test result shown was not valid as the von Mises stress was greater than the yield strength of alloy steel, which this part was composed of. As for kinematic movement, my project features movement of the principal control surfaces, ailerons, flaps, spoilers, rudder, elevators, and the rotation of the weapon. That's it, folks.